The question seems simple. You pour water on fire, and the fire goes out. Every child learns this. Every person on Earth has seen it happen. And yet almost nobody can explain the precise mechanism behind it. Because the real answer requires understanding something far more fundamental first. Fire is not a thing. This is not a philosophical statement, it is a scientific one. Fire has no mass. It cannot be picked up, bottled, or stored. It occupies no physical space of its own. What we call fire is not an object or a substance, it is a process. Specifically, it is a rapid oxidation reaction, a continuous chemical event in which a fuel source reacts with oxygen in the presence of sufficient heat to release energy in the form of light and more heat. Remove any one of those three inputs, fuel, oxygen, or heat, and the reaction cannot continue. The fire does not move somewhere else. It does not weaken. It simply ceases to exist, because the process that was producing it has been interrupted. This is known as the fire triangle. And water, it turns out, is one of the most efficient substances on Earth for dismantling all three sides of it simultaneously. The first and most immediate mechanism is thermal absorption. Water has an exceptionally high specific heat capacity, meaning it requires a large amount of energy to raise its temperature. When water contacts a burning material, it absorbs heat from the combustion zone at a rate that the fire cannot compensate for. The temperature of the fuel drops. As it drops below the ignition threshold, the minimum temperature required to sustain combustion, the chemical reaction slows and stops. But water does not just absorb heat in its liquid state. As it heats past 100 degrees Celsius, it converts to steam. And this phase transition absorbs an additional and significant quantity of energy called latent heat. A single liter of water converting entirely to steam can absorb roughly 2.6 megajoules of energy. That thermal extraction happens rapidly and directly at the source of combustion, pulling heat away from the reaction faster than the burning fuel can regenerate it. The second mechanism is oxygen displacement. As water vaporizes into steam, it expands in volume by approximately 1,700 times. That expanding steam physically displaces the oxygen surrounding the combustion zone, reducing its concentration below the level required to sustain the oxidation reaction. Fire needs an oxygen concentration of roughly 16% to continue burning. Steam expansion can drive local oxygen levels well below that threshold in seconds. This is why water mist systems, which produce fine droplets that vaporize almost instantly, are so effective in enclosed spaces. The rapid steam generation creates an oxygen-depleted atmosphere around the fire before the flames can propagate further. The third mechanism is fuel separation. Liquid water coats the surface of the burning material, creating a physical barrier between the fuel and the surrounding oxygen. Even after the initial cooling effect, this surface layer continues to suppress reignition by preventing fresh oxygen from reaching fuel that is still hot enough to combust. Three simultaneous mechanisms. One substance. Applied in a fraction of a second. This is what makes water so uniquely effective against most common fires. It does not simply interfere with one part of the fire triangle, it attacks all three. The heat is extracted, the oxygen is displaced, the fuel is separated. The reaction has no pathway to continue. Understanding this also explains why water fails, catastrophically, against certain fire types. Grease fires burn at temperatures far above water's boiling point. Introducing water causes instantaneous, violent vaporization that expands so rapidly it launches burning oil into the air as a fine, ignited mist. The fire does not go out, it explodes outward. Similarly, water conducts electricity, making it dangerous around live electrical fires, and it reacts violently with certain burning metals such as sodium and magnesium, generating flammable hydrogen gas. Water works because it attacks the chemistry of combustion from three directions at once. It fails when the chemistry of the fuel or environment turns those same mechanisms against you. Fire is a process sustained by three inputs. Water interrupts all three simultaneously, extracting heat faster than the reaction can produce it, displacing the oxygen the reaction requires, and coating the fuel the reaction depends on. That is not a simple answer. But it is the correct one. And the next time you watch water extinguish a flame, you are not watching a substance defeat another substance. You are watching a precisely targeted chemical intervention collapse, an ongoing reaction from every angle at once. That is why water stops fire.